We have 9 startups presenting today. They're each going to talk for 3 minutes. There's not going to be any Q&A. And they also have locations outside. You'll see their logos printed. So that's where you can find them during the networking sessions. And so first speaker.
Thank you.
There we go.
Thanks, Marcus. Always fun to try to slam 10 years of research into 3 minutes, so I will definitely try to do my best. My name is Andrei Sauer. I'm the founder and CEO of Greenlight Biosciences. This thing is not working. Okay. And you can see there what our MIT affiliation is. We're chock full of MIT people, chock full of MIT technology. Our chairman of the board is Charlie Cooney, who a lot of you know, and Bob Langer is our senior advisor. And it's actually a very simple venture. What we do is we make cheap, very high quality RNA. That's it. I could finish in 30 seconds. RNA, as you guys know, is the oldest biomolecule on the planet, 4.2 billion years old. And as many groups have demonstrated, if you have control over RNA, you can actually do a lot of things, a lot of really cool things, including protecting crops against pests. Historically, the problem, of course, has been making RNA is really expensive. You pay thousands of dollars a gram in order to make high-quality RNA. And when you're spending $1,000 a gram to make a molecule, you don't really want to spray it on a field. And so what Greenlight has been able to do is reduce that cost from hundreds of dollars or thousands of dollars to about 38 cents per gram, to the point where now it can be sprayed in a field and used as an insecticide, a fungicide, a herbicide, etc. We all know the problem, right? We lose a lot of our crops to pests. A lot of them have actually developed resistance. And to add injury to insult, we also have a problem with non-specificity. We're killing bees left and right. Neonics have been banned in Europe. Sulfosaflor, which is the alternative to neonics, just recently was published to be fairly damaging to bumblebees and bees. So we're actually getting to the point where we don't have any chemistries to protect our crops. RNA is a great alternative because it provides very high specificity to be able to control individual pests. As I said before, historically, the problem has been you can't produce RNA at high qualities and high quantities. We have solved that problem. We have a technology that is covered by about 60 patents. It is a quantum leap over traditional technologies. It's nothing like fermentation or in vitro transcription. It's a brand new method for producing RNA that is scalable and very, very economical. At the end of the day, the proof is in the pudding. You can see here a potato field in Wisconsin. On the right, on my right, you have a field treated with about 1 gram per acre of our stuff. Think about that. It's about a tablespoon of RNA dissolved in 20 gallons of water sprayed in the field, which provides 100% insect control. We were unable to find even a single bug left alive in that field, less than 2% defoliation and over a 50% increase in yield. You can see on my left, your right, the untreated field is practically completely destroyed. What are we looking for? We already have about 10 partnerships ongoing with both pharmaceutical and agricultural companies. We're looking for more. We want to bring this technology to market as quickly as possible, and specifically we're looking for partners that are outside of the United States or partners who can give us access to row crops. Thank you very much.
Good morning, everyone. My name is Philip Wender. I am a managing director of APT, Advanced Potash Technologies, and a former visiting scientist here at the MIT. We're essentially here to solve the food problem. And with the technology which was developed also at MIT, more specifically in the materials science department at the Allen NAB. So what is it that we are essentially trying to do, right? We believe that the best way of increasing yields is with fertilizers. If you look at nitrogen and phosphate, these are already produced in very large scales all over the world. The problem, however, with potassium is that its production is very much concentrated in certain areas, right? And moreover, the existing product, or MOP, potassium chloride, the way people call it, is suboptimal for several types of crops and soil types. So what we are trying to do, and we're going to do it, is essentially to do the same thing for potassium that the Haber-Bosch process did for nitrogen. So our solution, we call it hydropotash. It's essentially a high-quality fertilizer produced from feldspar, which is a silicate mineral pretty much available all over the world in every single country. Our product is a high quality and high efficiency fertilizer. So it is not a salt, which is very important, right, for biosolutions and all that. So we do not contain any chloride. We do not suffer losses through leaching with heavy rainfall and all that. We're organic as well, and we're compatible with biological solutions. So if you look at it, we essentially produce a fertilizer locally of high quality, and you eliminate a very big chunk of the cost, which is essentially delivery and logistics. This is our process from a very high level perspective. It looks simple. You need to understand it very well to get the best results out of it. Essentially, it's a hydrothermal process at 200 degrees Celsius where we mix feldspar, which is the rock on which you can see on your left. We mix it with a little bit of calcium oxide, water, take it to 200 C, and this is where we produce our fertilizer. Everything that comes out of it is essentially product or fertilizer. There's absolutely no byproducts or waste being generated in this process. So it's 100% yield. There we go. This is where you can see the efficiency of our product. So the third generation of product, we already see yield increase of roughly 30% compared to MOP. So this is very important. It's not compared to no application whatsoever. This is applying versus the existing product out there. We have done several greenhouse tests with different crops and different soils, and now we're moving to the field with big farming groups in Mato Grosso, the Brazilian Cerrado. And just to finalize, this is what we're looking for, essentially strategic and aligned partners to develop new products and enter new markets. As you can see, we work with several of them, organic producers, very large scale producers in Brazil, as well as research institutions, but we're always looking for more. So.
Good morning, everyone. Thank you so much for the opportunity to speak to you today. C2 Sense spun out of the chemistry department here at MIT. We've been supported by STEX 25. MIT is the engine and the Deshpande Center. So we're really excited to be part of this event. My name is Mary Smith, and C2 Sense is an industrial Internet of Things company providing a sense of smell for the digital world. Ooh. Not working? Yeah. There we go. Thanks. Gas sensing is inherently difficult. Most gases are invisible, and they typically involve a lot of complex mixtures of different compounds that are difficult to distinguish. You need something that's small enough, cheap enough, robust enough, and specific enough in order to capture this information and feed it into the wider IoT ecosystem. Nothing off the shelf solves this problem. And this is a significant problem in many markets, especially in agriculture and in the food supply chain. Gases are implicated in or result from crop health, food spoilage, and livestock health. C2 Sense is capable of addressing this limitation in practical gas sensing and mitigating some of these losses. And here's how we're doing it. Here you see the C2 Sense complete solution. At the bottom is our sensor hardware, shown here, and at the top is our custom analytics platform. I've brought one of our sensor chips, which you can see here. This is used in both the fixed and portable node. Our proprietary chemi-resistors contain carbon nanotubes and special molecular selectors. Electrical changes in this chip correlate directly to components of the gas stream, both the identity and the concentration. The data is transmitted wirelessly to our servers, where custom algorithms that we develop in-house process this data from raw electrical signals into actionable gas concentration. Using this approach, we can detect pretty much any gas we would like to. This particular chip can detect up to 16 gases. The customer selects their particular chip, and then they can view their processed data remotely in real time via our web portal from anywhere in the world. So this is what sets us apart from traditional sensor companies. The small size, weight, and power requirements of our sensors enable this IoT analytics stack. So I'd like to show you an economically relevant use case. Here you see a poultry grow-out house. Microbial breakdown of chicken waste leads to production of ammonia. That causes production losses. The chickens get sick and they die early. We have installed our sensor systems in 18 chicken barns in 6 states for pilot trials. And based on our platform, the growers can decide when to turn on their fans, bring in fresh air, and keep those chickens healthy, but not overventilate and run up costs due to excessive heating in the house. Based on our initial results, each of our sensor systems can save a grower up to $5,000 per farm per year. So in the US alone, we're talking about a total of several hundreds of millions of dollars. To that end, we're looking for potential partners and customers who are interested in agricultural gas monitoring, and we're also looking for partners who'd be interested in commercializing our technology for other industries, such as worker safety. But most broadly and importantly, we're looking for anyone who is interested in a new analytical data stream and a sense of smell for the digital world. Thank you.
Big green button, right? It's working. Okay, good morning, everyone. My name is Sorin Grama. I'm the founder and CEO of Transera. We're developing energy-efficient climate systems for indoor farms based on material discovered and developed here at MIT. We're a very early stage company. I'm just going to tell you about my journey and a few things that I discovered in starting this company. About a year ago, I was casting about for ideas for a new startup. I had just came out of a previous startup where I was doing refrigeration systems for agriculture, cold storage systems. And I thought maybe refrigeration is something that I could use for indoor farms. It was just an idea that was planted in my head and during one of my trips while I was working in India. So I went about and started talking to people in this industry. And I talked to over 200 people, mostly plant scientists, growers, greenhouse owners, vertical farm owners. And I was looking for ways that I could use refrigeration, my expertise. And a surprising thing that I discovered is that actually it wasn't cooling that was their biggest pain, it was moisture. Moisture control and humidity is the biggest problem that they have in indoor farms, especially hydroponic enclosures, closed enclosures where plants, high-density plants transpire a lot of water, a lot of evapotranspiration, water, nutrients coming out of the plants. And if you don't remove that moisture, you end up with plant disease and molds. So that was my first discovery. The second thing that surprised me is that there are no great solutions out there. The best thing that they use right now is HVAC systems, air conditioning systems that cool the air, and as a byproduct of that, they remove the moisture. It's very inefficient. They overcool and they reheat the air. It's incredible. As an engineer, I was just astounded. I think we have a better solution. Our material here is a desiccant developed at MIT. It's called a metal organic framework that has an absorption capability unlike any other material. It's incredible. It absorbs almost its own weight in water. And furthermore, more important, we can dry it or regenerate it, as we call it, with very low waste heat, so low temperature waste heat, which allows us to develop a new class of dehumidifying systems that are much more energy efficient, much simpler, low cost materials. So we envision a moisture management system that can be installed in vertical farms, such as a container farm. We dry the air and we basically reduce the energy consumption of that vertical farm by as much as 30%. Last thing I discovered, and this is a fantastic market, it's an incredibly growing market. It is growing at 23% a year, actually 23% a year, then not 20%, it's $6 billion by 2023. It's got fantastic opportunities for growing foods in urban centers using a fraction of the land, a fraction of the water, but the energy efficiency is its biggest Achilles heel. So we have to find a way to do that, and that's what we're set out to do. We're looking for partners to scale up this material, so chemical partners. We're also looking for manufacturers, traditional manufacturers, to help us build this device that encompasses the material. If you'd like to find out more, please come talk to me afterwards. Thank you.
Hi, everybody. My name is Mike Milley, and I'm here today to talk to you about Join Bio. We are essentially a company that is developing novel solutions for agriculture by engineering microbes. And this is our basic premise. As Andre mentioned earlier, chemicals in general have come under a lot of fire, from regulators. People are looking for alternatives. And one of the approaches that we're taking is to look at microbes from an engineering perspective, engineering them for very specific purposes. Let's see, do we get this? As Al showed earlier, we're a unique structure. We're a joint venture between Bayer Crop Science and the Leaps group at Bayer and Ginkgo Bioworks. And this is the MIT connection. I actually personally went to Stanford, so I'll make that confession. But the 5 founders at Ginkgo Bioworks all are from MIT. With their synthetic biology startup and venture over here down at the Seaport area. So it's a very unique situation where, unlike most startups, we actually have 2 parents, which provide a lot of resources and a lot of support that you don't normally get in an early stage company. When we formed this joint venture, one of the requirements at Bayer and with Leaps was it had to be a moonshot. And so we needed to pick a major problem, a big problem that people have worked on for a long time and not found any solutions to. And what we decided to focus on as one of our initial use cases was alternatives for synthetic nitrogen fertilizer. The nitrogen fertilizers account for 3% of all the greenhouse gas emissions out there, 3% of global natural gas, and most growers, most folks in the ag business would agree that if we continue to put out that amount of synthetic fertilizer, it is not sustainable. So people are looking for alternatives. One of the approaches people have looked at for years is trying to find natural microbes and using the microbiome and natural microbes in a symbiotic way so that nitrogen fixing microbe would transfer the nitrogen to the plant. And this has not worked. Okay, people have been looking for this holy grail for 30, 40 years, unsuccessfully, trying to mimic what happens in peanuts and in soybeans. And our approach is to find some of these host or chassis microbes, and then using the synthetic biology technologies in the foundry at Ginkgo Bioworks, and using the engineering technologies that have evolved over the last 8 years in synthetic biology, customize or optimize those microbes for very specific purposes. In this case, optimize them for nitrogen fixation and optimize them to performance levels that natural microbes that you find out there don't achieve. So that's really our premise. In terms of future partnerships and such, obviously, if we're highly successful with this, we're going to disrupt the fertilizer world to a certain extent. But we also could partner with them as a way to put the microbes out there. We're looking at major ag companies for field testing. But even more important, what we're actually building here is a platform that can be applied not just to nitrogen fixation, but also to disease and pest problems as well. So those partnerships will evolve. But I'll also put a plug in for Ginkgo Bioworks. They also, on the synthetic biology side, are looking for partnerships in the food tech, pharma, specialty chemical, and in the enzyme business. Okay, and thank you very much.
Hey, I'm Adam Behrens, CEO and co-founder of Cambridge Crops. What we're doing is developing coatings to extend the shelf life of perishable foods. I'm also a former postdoc at the Langer Lab. At Cambridge Crops, we're fighting the food waste problem by extending shelf life. Today, 1/3 of the food in the world is wasted, representing over $1 trillion in economic losses. And our solution is a silk-based coating, the same silk that's used in a silk tie, but much lower grade, originally invented by Professor Benedetto Morelli at MIT Civil Engineering and Professor Fio Omonetto at Tufts. We extract a protein from silk using a completely water-based process, resulting in a natural, edible, and really imperceivable coating that drastically extends the shelf life of perishable foods. Here it is applied to an avocado. At the retail level, 10 days room temperature storage. Most of you are familiar with an overripened avocado that's growing mold. And on the right, you can see our coating material, when applied to the outside of the avocado, is able to drastically extend the shelf life. The technology is really robust. It completely addresses most, if not all, decay mechanisms in perishable foods. This includes retaining water, limiting CO2 and oxygen transport, and slowing down contamination rates. The processing is completely water-based, both from an extraction and deposition method, resulting in a low-cost material with low raw material inputs. Really, our biggest advantage in the space is the ability to plug and play into existing infrastructure. Basically, we take our silk fibrin powder and add it to existing spray coater and bath washes already existing in process lines. The technology is also IP protected with a suite of patent applications. Technology is also really broadly applicable. Our initial investigation was on whole produce, but we've actually been exploring moving down the process chain and looking at ready-to-eat fresh-cut fruits and vegetables, as well as things like beef, chicken, and seafood. These areas are more heavily processed, have more washing steps, and have higher margins for our initial applications. But there are applications in pre-harvest space that we're not currently investigating. Our value prop is different depending on the customer. Producers see improvements in distribution, retailers see reductions in waste, and overall we can improve food accessibility and nutrition for the consumer. A quick example of value we bring to a potential producer, we had a pilot in the south of Spain with a large celery producer. The shelf life of celery is currently 14 days, only allowing them to access Central and Western Europe. Through a 7-day shelf extension, which is easily achievable with our product, they can reach the high-value markets of Northern Europe and Russia. We're looking for help with navigating the food supply chain, where to implement, who to sell to. Also interested in co-development, both in our core competency, which is shelf life extension, but in other pre-harvest areas as well. And looking at help with process optimization and scale-up of our extraction process. Thank you.
Okay. Good morning, everyone. My name is Fabrizio. I'm co-founder and CEO of Thrive, and MIT Sloan alum 2018, just graduated. I'm here today to tell you about this different kind of AgTech. It's a novel lending platform for farmers, built from scratch inside the MIT, and that ultimately has the ability to bring people to invest in the development of their own food. 75% of the food production in my country, Brazil, and our rich beachhead market is done by what is called the missing middle. Their financial needs are not large enough, much larger than it's needed for the microfinance, but as individuals, they are not large enough to be appealing for the large financial institutions. They receive 25% of the available credit, and they pay at least 30% interest rates per year. This is a $150 billion market opportunity just in Brazil. As a former lender, I know that the problem is not lack of capital. Lenders do have excess capital to deploy. What they don't have is access to these farmers. When they do, the data is insufficient, very hard to analyze, what brings the loans to be costly, and most of the time they just step out of this process and leave the farmers in the hands of very few financial players. This is where Thrive is stepping in and connecting the unassisted farmers with the uninformed lenders. For lenders, our machine learning credit risk assessment helps them make smart decisions based on alternative data and portfolio optimization. Besides, it helps them to monitor real-time the credit risk over the crop season with chatbots and remote sensing. For farmers, it builds a financial tool that helps them to understand what they should do in the future in order to pay less. Our pilot is being constructed right now in Brazil in a very simple structure that brings value to every player involved. For lenders, we increase the portfolio diversification and improve the risk returns. Input suppliers sell more inputs and lend less. Farmers receive more loans and cheaper capital. Trading houses increase their commodity origination, and we connect all the dots in the middle. We have a very experienced team. I used to be a credit instructor for almost 15 years. My other co-founder used to work for one of the largest agriculture players in the world, LDC, And we built our team here in MIT with technologists and social impact people. If you want to participate and to help us to develop this agriculture credit risk brain, please come to talk to us afterwards, either by data sharing, loans for farmers, or even by joining the team. Thank you so much.
Great. Big one? Yeah, cool. Hello. So I'm continuing the shift from molecules to data. This is not working. All right, great. It's working too much. So hello, I am Ray Goffer, co-founder and chief strategy officer of Climacell. I'm a recent loan alum from 2017. We're building a micro weather data platform, and I'm here to talk about its applications to agriculture. So a word about Climacell. We're global leaders in what we call micro weather data. We have blue chip customers in multiple industries, over $60 million in funding in less than 2 years, founded in 2015 by myself and two other co-founders coming from the Israeli Air Force. You can see some of our customers and strategic partners here on the slide. So what's wrong with weather data? Weather data is produced predominantly by three types of sensors. One is weather stations, so the local set of thermometer and anemometer. They have great accuracy but very poor coverage. On the other end of the scale, we have satellites, which have great coverage but very poor accuracy. Somewhere in between, in some places, we have radars that are not so great in either coverage or accuracy. This image shows the density of weather observations globally. And what you can see is that it correlates very strongly with GDP per capita, meaning that rich countries have very good density or relatively good density of observations, where the most of the world, look at Latin America, look at Africa, look at even India and Southeast Asia, have very poor access to weather data, which means that the quality of weather forecast in this region is maybe 20, 30 years back to what we have here in the US. It's very poor quality, and that's where most of the agricultural products in the world is produced. Here is the solution. What we're doing is called pure software distributed sensing networks. We're basically looking at how weather affect different things around us that are not weather sensors and translating it back to weather data. On the left side, my right, you can see a typical rural area in India, and it has 7 weather stations over more than 200 by 200 kilometers. On the right side, you see a cellular network. These are microwave links that are sensitive to weather. We use this data to get very granular understanding of rain in India, down to the minute, with over 150,000 sensors like this, compared with 1,500 that the government owns and operates. This is another image from Mumbai, one weather station from the government. All your weather apps are based on this one weather station. Here is what kind of understanding we have in just this city. We merge all this data with the traditional data sources coming from all the weather stations and Dopplers, and we fuse them together to what we call the fuse layer. We run our proprietary forecasting model that basically are able to use this data on a minute-by-minute 500 meters resolution all over the world and produce them and basically make them available through a dashboard or an API. We're looking for partners in the agriculture space. We have design partners in aviation, in mobility, and other verticals in utilities, and agriculture is the next thing for us. There are tremendous applications starting from precision agriculture, doing 500 meters grid minute by minute everywhere in the world, to crop insurance, of course, and disaster management. If this is interesting, come talk to me later.
Good morning. My name is Bakur. I am a co-founder and CEO of Z-Tractor. I am an MIT graduate. We have a few other folks from MIT. And we are considering to use some MIT technologies in our autonomous electric tractors. You all seen these pictures, and you can also relate them. What it's about, somebody mentioned here, maximizing resource use and increasing efficiency. What we believe is that next generation of the tractors should be electric and autonomous, and that's what we are building. to address the problems, problem number 2 and number 1 and 2 is obviously with the bringing alternative power, which is lithium-ion batteries, and reducing emission. To address number 3rd problem, which is labor, it's autonomous driving and operation, which is increasing efficiency. To address the maintenance problem, I was running a tractor rental company, and what creates the problems, it's diesel-related technologies, which are costly to replace, and it's human drivers. So we address this problem with electric and autonomous. And that's the driver errors. You see the pattern is not very clear and it's true for any operation. So lithium-ion batteries made possible trucks, buses, cars, bikes, scooters, and we believe that now time is for tractors, and we offer all-electric autonomous tractor with the robot tractor, basically with the no diesel, no driver. What we are looking for is partnerships and early adapters. We have few food companies who are considering to order our tractors and gain the rights to use the label, which is unique to every autonomous electric tractor, which is zero emission farm product label in blue color, which is becoming quite popular. Thank you, and looking forward to see you by our booth outside.
Thank you, Baku.